When I was doing college, it was tough for me because I only had basic foundations in math and I struggled. So when I became a teacher, I wouldn't like my students to experience the same. So I started devising easy ways to manipulate complicated things. Now, you will study inverse of a matrix, and that topic is one of the most difficult things to understand regarding matrices. So to do inverse of a matrix, you should understand first what are determinants for and what's the meaning of an identity matrix. Let's go ahead and study what determinants are for. So determinants is simply the difference of the cross products of the elements. So you have A times C, the determinant of A is equal to A times D minus B times C. So it's the cross product down first and then up. Alright, now if you have the matrix B, you want to find its determinant. So that would be 2 times negative 2 minus, alright, don't forget that, 3 times 5. And so you have negative 4 minus 15. And that gives you negative 19. So if you have a series of negatives, simply add them and copy the sign. So that's how determinant works. And in linear transformation, you can actually solve a system of linear equations by means of determinants, because the value of x is actually the same as the determinant of x divided by the determinant, and the value of y is equal to the determinant of y divided by d. So the first thing you do is to take out those numbers and form them into a matrix. That's 2, 1, 3, negative 2, and 1, 4. And of course, this will be for your x term, your y term, and your constant value. And if you still remember, I always put like a dash to separate the constant from the variable terms. So first is, we will have to do the determinant. Determinant is dealing with the x term and the y term and their coefficients. So that would be 2, 1, and 3, negative 2. So you have x and y. And then you take the determinant. So you have 2 times negative 2 minus 1 times 3. So that would give you negative 4 minus 3, which is equal to negative 7. Okay, so that's the value of the determinant. Alright, now we would like to find dx, so that if we divide dx and d, we can identify the value of x. So what happens here is that in place of the x term, we will put c, and that would be 1, 4. And in place of the y term, it would still be the same. Alright, so as you can see, I have 3 different letters, x, y, and c. Alright, so we take the determinant, so 1 times negative 2, down first, and then go up, 4 times 3. Alright, down, and then go up, equals negative 2 minus 12, which gives us negative 14. Since the value of x is dx over d, and dx is negative 14, divided by the determinant, which is negative 7. So therefore, the value of x is positive 2. Alright, now we will deal with the value of y. So we know it's dy over d. We already have the value of d. So we will find first the value of dy. So to find dy is, in place of y, we will put c. And then, of course, copy your x. And then, you get the cross product. So 2 times 4 minus 1 times 1, which gives us 8 minus 1. 2 times 4 is 8, and 1 times 1 is 1. That gives us 7. And so, the value of y is dy over d, and our dy is 7, and our d is negative 7. So therefore, the value of y is negative 1, which gives us the solution to be equal to 2 and negative 1. That is, your x is 2 and y is negative 1. Let's prove that our solution is correct. So what we can do is to substitute the value of x and y in our equation, and hopefully they are the same. Let's see. So you have 2 times 2 is 4 plus negative 3, which gives us positive 1, which actually tells us that. Alright, now we'll go to the second equation. You have x, which is 2, minus 2, and our y is negative 1, which actually gives us 2. Negative 2 times negative 1 is positive 2, and that gives us 4, which actually states that. Therefore, alright, our solution is correct. So it helps to know this type of solutions because when you go to college, they will be explaining this. I wouldn't like you to get lost. And also, understanding identity matrix is only referring to a certain matrix whose diagonals are just 1. We can only have identity matrix if our matrix is a square matrix. What is meant by that? It has the same row and the same column as was explained to you before. So this is a 2 by 2 matrix, and this is a 3 by 3 matrix. So this is an identity element for a 2 by 2 matrix, and this is an identity matrix for a 3 by 3 matrix. And that's it.